Hi everyone, welcome back. If you're new here, my name is Micah, and this channel is dedicated to learning, teaching, and discussing everything about cybersecurity. So today we're in TryHackMe, and we're doing Boss of the SOC, and this is an offering from Splunk. It's basically like a CTF. They give you scenarios, and you have to go in there and basically figure out all of these different things about what happened, who it happened to, and whatnot. So this is just a intro to Splunk. This is not like the end-all be-all. If you're working in the actual SOC, you'll see other Splunk offerings like Enterprise Security, UBA, Phantom, or SOAR. I think that's what they call it now. So this is like the very base level of Splunk that you'll be working with. And every offering of Splunk comes with search and reporting, so it's a great thing to learn, especially getting familiar with SPL and searching and whatnot. But without further ado, let's get straight into it. But if you go to App, Search and Reporting, there's a little drop down. They go to Investigating with Splunk Workshop. And then hit the next tab at the bottom. We can kind of go over all of the different data that is in this Splunk instance. So you see that we have some Nesses, DHCP, LDAP, IP. What else do we have in here? Actually, this is a better view here. So this little description says the environment included a Nessus installation for vulnerability scanning, Fortinet next-gen firewall to capture traffic and provide web proxy services, a forensic SIF server, and some other stuff. I'm not going to read it all, but it's really important to get familiar with your data before you start searching, because then it saves a lot of time if you know where stuff is and you know exactly where you want to pivot to. So I highly suggest to come in here and anything that you're not familiar with, just get familiar with. It's scenario 1, the APT prologue. So in this scenario, reports of the below graphic come in from your user community when they visit the Wayne Enterprises website, and some of the reports reference Poison Ivy. In case you were unaware, Poison Ivy is an APT group that has targeted Wayne Enterprises. Your goal as Alice is to investigate the defacement with an eye towards reconstructing the attack via the Lockheed Martin kill chain. And as you see here on the right is the kill chain, and we're going to use this to kind of visualize the attacker's steps, and it makes this whole scenario make more sense. So on to the first question. What IP is scanning our web server? So let's go to Splunk. Let's search on index. That's BOTSv1. It's the only index we're given for this challenge. Source type will be stream HTTP, because we're looking for HTTP traffic. And then we're going to do top, and then we're looking for the top source IP. And the reason we're looking for a top source IP is because we're betting that, the destination IP. We're betting that the IP with the most traffic will be our web server, because compared to the other IPs, we should see way less, because this host is talking to thousands or millions of hosts out on the external internet or the World Wide Web. So let's look into this 192.168.250.70, and we can just remove that and then click into here, or actually just copy this, I guess. Dist IP equals that. And so we can take a look around, see what kind of traffic is generating. A tip is to look at the HTTP refer, because this basically refers to where this content is coming from. So we see that a common trend here is this "I'm really not Batman" in all of these HTTP referrer strings. So it's a safe bet that this is our web server, or our domain name here, this "I'm really not Batman.com. So let's look back at Splunk, or TryHackMe. third question is actually what is the IP address of our web server, and we have pretty high confidence that this is the correct answer. Oh, cool. All right, so let's try to find what IP is actually scanning our web server. So since we know that our destination IP will be this internal 192 address, we'll be looking for the top source IP because usually web scanning or vulnerability scanning creates tons and tons of traffic. So we should be able to find our culprit by searching for the top source IP. And this 40.80.148.42 seems to have just a tremendous amount of traffic coming from it. So let's check this out. All right, let's dig into one of these packets and see what's going on here. So we see that I'm really not Batman. Looks like it's using some kind of system here. Joomla is a content management system. So it's maybe something to note, to keep in mind for the future. Actually, the second entry down, we see that we have some web scanning information here. It's Acunetics. I don't know how you say that, but it's a web vulnerability scanner. And that is coming from that 40.80 address that we found just a second ago. So I believe we have two more questions that we can answer here. So what IP is scanning our web server? And we determine that it's that top source talker, and that's at 40.80. What web scanners scan the server? And that's the I can't say it. What content management system is I'm really not Batman.com using? And we determined that was Joomla. And usually if there's something in here that I really don't understand or I've never seen before, like Joomla or whatever it may be, that web scanner, I'll Google it, just try to find any information on it just to confirm what I'm seeing. You don't want to just kind of just scan over stuff and then not understand what you're looking at. So that's always a good pro tip. So on to the next questions. We'll be looking into an IP address that's performing some kind of brute force attack, and then answering some questions about the passwords and other things regarding the brute force attack. So let's move back into Splunk. All right, so now we want to filter on HTTP post requests. We're looking for any data that's been sent to our web server, i.e. usernames or passwords. So let's remove the source IP and let's filter on HTTP method field, and that contains the post, get, whatever requests to our web server. And I don't believe it has to be uppercase, so let's do that. And then in this data here, we see that we have the form data. And if you're familiar with HTML, that you know that forms are usually the primary method of uploading or entering passwords, usernames. So let's go ahead and filter on this as well. I'm just going to copy and paste this. And then in that form data, we're looking for any fields or any strings that contain password, or password spelled like this. It's another common way to enter data into the forms. So let's hit enter. And then last step, we're going to pipe that out to a table. We're going to do it by time, form data, and then the source IP, so we can see who the top talker is. And already you see that this 23.22 is the top talker and is responsible for the bulk of these logins. So pretty high confidence that this IP address is performing the brute force. And then we can go ahead and enter that into TryHackMe. Awesome. So now we have that question answered, and we have enough information to go on to the next one. So it says, what was the first password attempted in the attack? So let's go back to our search here. Let's filter on time. and we see that the first password was 1234567 8, and you'll notice throughout the entirety of these entries that it starts with password equals then the password, and then it ends with the ampersand. So we'll get to that a little bit later, but that's something to keep in mind. So let's go back to TryHackMe, and it is 1234567 8. Awesome. So the next few questions are going to require a bit of heavy lifting, and we're going to do that. Basically what we're going to do is we're going to filter out the password field, or this password string, from this form data. So we're going to use rex and a bit of regex to make this happen. So let's look up rex documentation. And so use this command to either extract fields using regular expression and groups, or replace or substitute characters in the field using set expressions. And here is the syntax. It's rex and the field that you're going to basically pull out, and then the regex expression. So back into Splunk, let's remove the latter end of this SPL, and then we're going to shift enter, and then we're going to start typing. We're going to do rex field, and we're going to filter on that form data where that password resides, and we're going to say password equals, and then remember the syntax is basically a question mark, and then the name of our new field that we're going to create, and I'm going to name it password. And then you know what, let's actually test this. So I pulled a few strings out of the events that were returned here, and we're going to craft a regex expression using the this regular expressions room and regex101.com. Basically what this is saying is password equals, we're looking for the string, this specific or explicit string, and then we're going to say matches any character word, and TryHackMe explains it a bit better, matches an alphanumeric character like A or 3, and that's A to Z 0 through 9 using this lowercase w, and then the uppercase is matching a non-alphanumeric character like these special characters. And then for both of them, we're going to say one or more times. We don't want any empty strings, and we want to make sure that there is at least some data that's being returned. And then this last part is basically we're excluding the ampersand at the end. So as you can see in these examples, for match 1, we have password equals Batman, and then it stops right here at the ampersand, and the same for the rest of these. Stops at the ampersand, and here you can see we have a special character, this pound sign, and it stops as well. And our last, the only, I will say, downside to this this regex query is that if you have a password like Sally and Johnny, you have that ampersand in the middle of the password, then we're only going to get half of the password returned to us. So that's just a downfall, and this is very simple. So I'm sure that with a bit of critical thinking, you could figure out a way to overcome this little setback. But anyways, let's get back into Splunk actually. Let's finish crafting that query. So let's actually copy down this part here. And once we have the regex copied into our SPL, we can see exactly what it's doing. So again, we're looking for strings that have or that contain password equals, and then we're using this parentheses to basically capture everything beyond this equal sign. So this is the field that we're extracting and renaming or creating called password, and then whatever regex is in here is going to be returned. All right, so we can go ahead and search and see what comes back. Oh, whoops. Let's do table and then password. and we should see our extracted fields. Okay, that's weird. Okay, here we go. So with this, we just looking for any field that that's not empty, pretty much, where password is not equal to blank space. And you can see what we're getting returned. Actually, I don't think there's any special characters or numbers. I think it's just straight like text, alphanumeric stuff, at least. So we really don't need that part. But I'm just going to keep it regardless because it's not hurting anything. All right, so now that we have a list basically of the passwords, now we have to figure out where the 6-character passwords are. 6-character songs or passwords. All right, so let's use the eval. And again, let's look up the documentation. The eval command calculates an expression and puts the resulting value into a search results field. So again, we're creating another field, but this time we're using math. So let's use eval and then password length or len equals and len of password. So we're creating a field called password len that equals the length of the password field. So for each one of these field entries, we're going to get a length back. And so let's do table password. Oops, forgot the length. Let's just see what it's doing. And okay, so you can see, let's try to not look at bad words. Animal, 6 letters. Bill, 4 letters. So you see what it's doing. It's just basically getting the length of these strings and then returning it here. So we are looking for strings where password length equals 6, right? And then we're going to return those passwords. All right, now cool. And we see we only have 6 letter passwords being returned to us now. All right, so we're good on this end. So again, the question was one of the passwords in the brute force attack is a Coldplay song. So let's close these out. And we're going to go to Wikipedia. I always do that. And we're going to look up Coldplay. We're going to try to find their discography or like a list of their songs, basically. Or let's just Google song list. List of Coldplay songs. And here is a list, and it's not the cleanest. You see that there's like emojis and there's quotation marks and whatnot, but we can fix all that stuff. So let's go ahead and copy all of this stuff down, all their songs. Wow, that's a lot. And let's copy that, and let's open up Excel. Try to make this look a little bit better. And let's see, no fill. Yeah. This is not necessary, by the way. Well, this part isn't. Just trying to make it look a little cleaner. And then let's Control All, and where's it? Control F. And we're gonna replace all of the quotation marks with nothing. So replace all. And we're going to save this as a CSV file because we're going to then import it into Splunk. So save as. I've already had this saved somewhere. So I'm just going to go back to Splunk. And then up at the top right, you want to go to Settings, Add Data. And then we're going to look for Upload, select File, and then coldplay.csv, or whatever you named your file as. We're going to upload it, hit Next. Make sure that your source type is CSV, and then you should be good to go here. You can already see the list of songs here. In the Review tab, we're going to make sure that this is a constant value, and then I'm going to change the host's field value to CP songs, Coldplay songs, and then add that to the BOTSv1 index and hit Review. And we have uploaded file. We have the name of our CSV file, the source type, the host, and the index. So let's copy this because I will forget. Hit submit. All right, so file has been uploaded successfully. All right, let's go back, pivot back to this SPL that we wrote just a second ago. And we're going to use lookup. And once again, let's go to Google just to make everything really plain, because I'm not the best at explaining things sometimes. So lookup. And so the description says use the lookup command to invoke field value lookups. So apologies, I have some technical difficulties and I have to use the Splunk BOTS instance hosted by them instead of my virtual machine because it stopped working on me. So this is going to be a little bit different, but I'm going to walk through the steps like what we just did to explain it better. So we're going to, basically this is the input lookup, the CSV file that we uploaded earlier. And let's just see what kind of data is returned. And we see we have a field named songs, and it contains all of the songs that we found on their Wikipedia, right? So what we're saying, what this command is saying is take that input lookup. We're going to evaluate this songs field, convert it to lower. That way it's normalized whenever we're searching on it. And we're going to take that songs field, right? That's now all lower. And we're going to output it to a new lookup. And this one's called coldplay.csv. So before this was coldplay.csv, and then this one can be like coldplay1 or something different than this one, basically. All right, so now that we have a new field, a new normalized field created in our lookup, we can compare the lookup that we just imported to our data from the password spray. And we're looking for the Coldplay song that was used as a password, remember? So we're going to compare the two data sets using the lookup command. And let's look up some syntax first. So it says the description is use the lookup command to invoke field value lookups. And we're going to be using this syntax here. So it's going to say lookup table name. That's going to be the coldplay.csv. Then the lookup field is the field that we just created, which is song, the normalized lowercase field. And then we're going to compare it to password. And I believe that's it. Oh yeah, and then we're going to output a new field that we can look up on, and it should contain any data that has correlated between the two data sets. So let's go back to our old SPL with the stuff that we were working on earlier. And we're going to say lookup. Oops, caps. Lookup. We're going to say coldplay.csv. And then the song as password, output new, and song. So we hit enter. We should see which password. Whoop, remove this. Oh, I'm sorry. We need to search on our new field here. So let's say search song. And it would help if we had a table to look at. All right, and there is our answer here. And we can just double check. Yellow is the name of a Coldplay song. So let's go ahead and enter that bad boy, and it is correct. So the next question is, what was the correct password for admin access to the content management system running I'mReallyNotBatman.com? So in this question, we're going to be looking for the password that shows up 2 times, basically. The first time being it ran through that automated scanner, whatever they're using to brute force. And then, it returns that 200, which signifies a login. And then the attacker testing that password to make sure that it's actually valid. So let's go back into Splunk, and we can close out some of this stuff. And let's go ahead and remove all of this. And we're going to be using the stats command here next. We're going to say stats because we want information about how many times this thing has occurred, or this password has occurred. Count by password. So we're figuring out how many times each password has shown up. And then we're going to do table. I hate that. And we want the time, password, and then the count. All right, awesome. So we see that the password Batman is the only password that has been used twice. So we're fairly confident that this is the correct answer. So let's enter Batman. Awesome. So in this next question, we're going to continue to do more math. We're looking for the average password length that was used in the brute force attack. So back in Splunk, we're going to remove this again. And then we're going to evaluate basically the password field. And we're going to get the length of each password. So we're going to use eval. String length is our new field. And then we're going to look for the length of the passwords. And then we're going to get the average of the lengths, and we're going to output that information. So it says the average string length is 6.17. So we can now take that information back to Splunk, or to TryHackMe, and see if our answer is correct. And it is. All right, so in this next question, we're basically looking for the amount of seconds that elapsed between the time that the brute force password identified the correct password, which is the Batman, and then when the time between that and when the actual login was used. So we're going to be introducing a new command called transaction. And The transaction command finds transactions based on events that meets various constraints, and it adds 2 fields to raw events. Those fields being duration and event count. We're looking for the duration of this event in this instance. So let's remove this. Say transaction, password, and then we're going to pipe that out to a table. And use our new field duration. We can find out exactly how long that took. Oh, I'm sorry. So we want to change. We only want the form data that contains that password of Batman. So we can do it like this. We know from the previous example kind of how that form data is structured. So I'm just looking for the form data that contains password and then Batman. And this should give us the right information this time. So it says 92 seconds between the time that the correct password was found and the attacker used that password to actually log into our systems. So let's go back into Splunk, or I keep saying that. Let's go back into TryHackMe, and 92.17 looks like if we're rounding up. And that's the correct answer. All right, so we can keep trucking along. So next question, how many unique passwords were attempted in the brute force attempt? So again, we're going to be introducing a new command, and it's the dedupe command, and basically it removes duplicates. Well, I guess I really don't need to look that up, but we can anyway since we're here. But it removes the events that contains an identical combination of values for the fields that you specify. So we're basically removing any duplicate passwords using the dedupe command. And then we want stats, and then we're going to count how many unique passwords were introduced in the attack. And let's remove this because we're only filtering on that one password. Now we should be able to see everything. So 412 unique passwords. Let's see, the next question was, what's the name of the executable uploaded by Poison Ivy? So we're going to be looking in the web proxy for any files that have been uploaded to our web server. So we can remove all of this actually. And we're just going to keep the source type field, but we're going to change it to our web proxy, which is that FortiGate, I think Unified Threat Manager. And we're going to just look for basically any exe files that we can find. Maybe there's some, maybe there's not, but it's a good place to start. So we see several exe files here, and actually the first one we see is, actually let's do this also. Anything that contains virus. And we have one entry here. And it looks like this file name 3791.exe was flagged as a virus. We can check the source of this this executable, and that is one of the IP addresses that we identified earlier as being part of the threat infrastructure of Poison Ivy. So let's enter this into TryHackMe. And that's correct as well. So what is the MD5 hash of the executable uploaded? So let's go back into Splunk, and we can close some of this other stuff out just to keep it a little more simple. And if we expand this caret here and we go down to the actual like meat of this event, we see that it contains a file hash. And anytime you find a file hash that is questionable, you can take it to VirusTotal and check it out. So let's enter that hash, remove the white space, and ooh, it is flagged by almost every single detection engine. So let's go to the details, and I believe we're looking for the SHA or the MD5 hash. So what did we just enter? We entered the SHA-256 hash, and these are the different hashes that have matched this same file. So we know with high confidence that this should be the MD5 of that file that was uploaded. And again, let's remove the white space. I'm not sure why it's doing that. And that is the correct answer. So what is the name of the file that defaced the I'mReallyNotBatman.com website? So when I first saw this question, what came to mind is that, the 3791.exe was basically some sort of dropper, and it went to go, pull down some more malicious code from like a C2 server, or, whatever happened. Whatever defacement happened after this executable was uploaded. So let's look at the time or the events that happened after this time. And let's remove all of this, these search queries here. And if we want to filter further on this data, we can actually do source equals our web server. And I believe it was at 192.168.250.70. So we can say source or dests equals our web server. That way we can just only see the things that pertaining to this attack. And I always like to look at all the fields here on the side, and one thing that sticks out is this category field. And we see that there are malicious websites that have been accessed in the past here. So like right off the gate, you see that this URL redirect is pointing to this poison ivy is coming from for you JPEG. So this must be the image that has defaced our web server. So let's go ahead and copy that and paste that here. This attack used dynamic DNS to resolve to the malicious IP what fully qualified domain name or FQDN is associated with this attack. So if we go to the event that we found just a second ago, we actually see the host name and the FQDN is listed right here in our event data. So I'm not sure if it's this entire thing or if it's just, or it looks like it's the entire thing. So what IP address has poison ivy tied to domains that are pre-staged to attack Wayne Enterprises? Again, this information is found in our current event data. If we scroll down, we can see the IP address that has been used to attack our website. And let's just double check. And that's correct as well. So for these last couple of questions, we're going to be using a bit of OSINT, and we're going to use the IP address and domain FQDN from the past two questions to answer these last four questions. So let's take this IP address and let's go back into VirusTotal. And I believe in the first question, we were looking for an email address that is associated with the Poison Ivy APT group. So here under details, you can see some of the Google results, and it's showing that this IP address is being entered into different OSINT search engines. So we have Alien Vault, we have Threat Miner, we have Threat Crowd, some other stuff. And we can just look at the relationships between this IP address and some DNS or domain names. So we see Wayne Core Incorporated, we see poisonivy.com, and let's actually search this or look this up. And we're going to use OTX for this. So let's do poisonivy.com, and we're just looking for an email, and we see that this domain abuse, but this is more along the lines of like a web admin or whoever's hosting this website or this domain. So if we scroll down just a little bit more, we see that there is a name tied to this poison ivy domain, and it's Lillian. So that's interesting, something to note. And so we're not finding an email. So let's search that same domain in VirusTotal. And let's just make a duplicate tab. Details, relations, and still no IP or no email addresses. And we can check threat miner as well. But we do see a lot of malware samples here and threat miner. And that's something that we can check out. I believe that's the next question. But let's stick to this one for right now. Oh, actually, there's more fields here. Oh, here it is. So we have an email, lillianrose@poisonivy.com. So this is the only @poisonivy email address that we found. Let's try this out. And remove the white space. And that's the correct answer. So now we're looking for a malware or custom malware attached to spear phishing emails that has been used in the past, and as part of the group's TTPs, their tactics, techniques, and procedures. And so just a second ago, we saw that ThreatMiner had several different files or malware samples from that IP address. And the most notable I see here is this, the one that starts with C99. So let's check out this in VirusTotal. And we have the MD5. We're looking for the SHA-256, I believe. Yes. So let's check that out, the MD5 in VirusTotal, and let's see if we can get the SHA-256 back. And we can just test these 3 different files and see, because I believe that's the only entries that have been tied to this domain. And so it has to be one of them. And luckily, it's the first one that we tried. So what special hex code is associated with the customized malware discussed in the previous question? And so let's check out VirusTotal. And I believe it's a little Easter egg here in the community section or community tab. And it might be a little hard to read with the dark mode on, but at the very bottom you see Ryan Kovar, and there's this special hex code listed at the bottom here. And this is the answer to this question. And last but not least, let's decode that hex file or that hex code. What am I looking for? Let's go to CyberChef. It's an amazing tool to do this kind of things. And let's input that hex code, and let's say from hex. And we get the output that says Steve Brandt's beard is a powerful thing. Find this message and ask him to buy you a beer. And I believe with this last answer, we are done with this section. So that was a pretty long walkthrough of the Splunk Boss of the Socks version 1. And this is a pretty old data set, but it's really good for learning SPL and the different commands that Splunk offers. Looking to do more content like this in the future, so if you find any value or found any value in this video, please let me know. And as always, leave a like, comment, and subscribe, and I will see you next time.